brightly.
I'm sure all of you have heard about the industrial Internet of Things or the Internet of Things in general in the consumer markets. So we'll go just, kind of level set there a little bit and talk about that. And then I'd like to get into and talk a little bit, and this will be fairly technical, about the challenges of the Internet of Things, and then finish up with the benefits. So what is the goal of maintenance operations? It is to maximize overall equipment effectiveness. This is calculated from three components. First, availability, which is basically the loading time minus the downtime divided by the loading time. You'll hear through all the publications, through all of what people are talking about in the industry, availability is synonymous with equipment uptime, and also with equipment reliability. Is the equipment running? How much of it is running based on the design amount of time that it's designed to be running? The second component of overall equipment effectiveness is performance efficiency. Not only do we want to make sure the equipment is up and running, but we also want to ensure that it is running at the designed rate of that piece of equipment. All the financial data that is set up, and when you're creating a manufacturing process, when you're doing a capital improvement project, is based on the performance of that piece of equipment. So maintaining that equipment and ensuring that it meets performance efficiencies as designed is a big part and a big component of the maximizing our overall equipment effectiveness. Also, finally, it's the quality that is being produced. So it can be running all the time, and it can be running at the design performance rate, but if it's not creating quality products, then obviously we are not achieving the goal of our operations. What is the industrial Internet of Things? It's the combination of machine learning, process control data, sensor information, machine-to-machine communication, and big data analytics to enable the advances in business insights. And in our world of asset management, it helps lead to improvements to our predictive and preventive maintenance methodologies. Probably the simplest, and I've been in the industry for 20 years, and I remember in my first year going out and actually probably doing a little bit of the industrial Internet of Things, and that I was integrating a work order management system with Wonderware, and taking the operational parameters that Wonderware was tracking and then generating work orders if those parameters got out of set points or had a failure or error code to create work orders automatically. So we've been doing the industrial Internet of Things for a long time. It's just that things since really 2006, 2008 have really started to explode as we've started to get advances in technology that allow really everything to communicate back and forth between each other. So what are some of the challenges of the Internet of Things? We're going to talk about lack of standards and communication protocols, system integration limitations, the volume of data that's being collected or that may want to be collected. And then finally, obviously, with all of this information traveling either within your network or out in the cloud, what else is the most important but security? So some of the challenges, and really it's the challenges that I've faced in technology over the last 20 years, is for things to be able to communicate back and forth between one another, there has to be standards. And currently there are a lot of organizations that are starting to produce the standards, but there's not one organization that is becoming the de facto organization, and I think that's what we'll continue to see. The International Telecommunication Union, obviously, all of this information is traveling through telecommunication networks. has global standards initiatives to ensure network and technology seamlessly connect. The IEE, the IEEE, so the Institute of Electrical and Electronics Engineers, has drafted standard P2413 as an architectural framework for the Internet of Things. Obviously, they're one of the most, have the most to gain from the standards organizations, as they are the ones who are defining a lot of the hardware that's being used to communicate across these networks. The OMG, or the Object Management Group, has multiple initiatives to ensure that the communications between these devices and sensors and equipment are successful. And these lead things like Data Distribution Service, or DDS, for network interoperability. Dependability Assurance Framework for safety-sensitive consumer devices like automobiles. So how do we create a framework to ensure that things that are being communicated that could lead to, from a safety perspective, like two cars not crashing into one another, how can we assure that communication is effective? Because obviously, if you can't trust it, then the adoption rate will be very low. Threat modeling. Again, this goes back into security. The standard for ensuring that these devices can communicate with one another and communicate if there's a potential hacking or a security attack between them, and share that information so that they can learn from that and be able to mitigate it. Structured assurance case meta-modeling. Another standard that's important, because what you have to do as you continue to do self-discovery of these devices is that you want to make sure these devices and the services that are going to be utilizing them have a definition of safety, of reliability, of integrity, and privacy contracts that are necessary to ensure that all of this is automated as much as possible. Among many others that the OMG is focusing on to improve the standards. Still, a single standard is unlikely, and the industry-specific standards will probably and most likely emerge, and these will be in the manufacturing sector, the telecommunications, facilities, consumer products, etc. The next challenge would be what protocol to use. Again, a lot of the communication that is occurring and the information that is being obtained are being obtained from very small devices with very limited bandwidth capabilities, very limited power capabilities, and very limited RAM or memory capabilities in the machines that they're using on board the devices. So some of the protocols that are being used to communicate between these are things like REST, which is representational state transfer. It's a web transfer protocol providing a uniform stateless interface. This uses things like, and you may, if you understand HTTP and HTML, you're basically using methods like get, put, post, and delete to communicate data over Internet Protocol communication. You can use inside of these protocols, you may have heard of XML or JSON, and these are the methods and the communication languages that are used to communicate the data. They're used to, REST is used to program applications, to manage information and workflow. And it's probably the highest level. You'll see that REST is being used in both devices as well as in the applications that those devices are communicating to, whether it be your asset management solution, your ERP solution, and so forth. Constrained Application Protocol, or COAP, is another web transfer protocol to use when there's constrained nodes and constrained networks. It is very efficient. Like REST, it's used in like REST, in that the APIs provide gets and uses gets and puts and post and delete methods. And this protocol is used a lot of times when you're on micro devices. So, again, a lot of the sensors that you may see through your facilities, where 10 kilobytes of RAM and 10 kilobytes of code space can be used to obtain the information that the sensor is obtaining and then communicate that to the network so that it can be used for informational and analytical purposes. XMPP, Extensible Messaging Presence Protocol, is again based on XML. It's an open standards protocol, and it's an example of something that's used in the smart grid or communication between smart meters, smart appliances, renewable energy resources, and energy efficient resources, and used a lot in electrical transmission. Another protocol that can be used to communicate the information that's coming from these devices. And then finally, Mqtt or MQ telemetry transport is a publish and subscribe simple lightweight messaging protocol. This is used and designed to minimize network bandwidth by using, again, mainly putting the information, publishing the information, and allowing other devices or services to pick up that information from the published data. Again, designed to minimize network bandwidth and device resource requirements while ensuring that you have reliability and the assurance of delivery. Next, we're going to talk about what do you do and how can you get this information into your systems that you're using. So the most important question that you probably can ask yourself if you have a work management system or a CMMS or an enterprise asset management system, or if you're wanting to integrate this data into an ERP system, does your system support a web-enabled API to communicate with these sensors and devices? As we get into the benefits of this, this is one of the most important components and challenges of the industrial Internet of Things. Does it support web services? So utilizing the protocols that I had mentioned in the previous screen, can those protocols communicate to your application the data over those communications? The second thing that you need to really think about is how does your system handle authentication to ensure the interface is secure? Obviously, you're not going to be opening up your applications. You most likely have sensitive data in there. You could have financial information. So how are you going to communicate, and how are those devices going to assure that they are who they say they are and have an authentication method that can communicate to your data and send it in? Next, we need to talk about big data. So over time, we've always collected a lot of information. Over the last 20 years, I've seen companies add data and more data. They're using Oracle and SQL Server and IBM database platforms to store this information. And it's important to understand that as we start to want to look at the interactions from all of our devices that are in your manufacturing facilities, how do we take that data and glean insights out of it that we haven't had the capability of doing before? Before, if you wanted to get information into your asset management system or your CMMS or your work management system, pretty much the only way to do that was to go around and manually collect it and enter it, usually on a pad and paper and then going back to the computer. Today, you're going to have the capabilities of going out and collecting that information, operational information that can help you make decisions. But the one thing you have to be careful of is that you don't overdo it and clog your networks. So the big thing is do not collect data just to collect data. Ensure that rules engines are deployed to analyze data trends. So at the devices themselves, can you implement rules engines that can take the data, whether it's a temperature reading that's being done on a continuous basis or every second or every minute? Can you take a rules engine and place it on the device so that the information that it's going to communicate is only the information that will actually help you make decisions? So by ensuring that the rules engine can help analyze data trends, can look at measurement set points and triggers. So while the data networks and storage devices are plentiful, and obviously the prices of having networks throughout your facilities, the prices of having storage devices to collect and store this information has become cheaper and cheaper, there are still limits, and you want to make sure you don't overwhelm the capabilities that you have within your organization if you don't optimize being able to prioritize the data that you share. When insights can only be garnered by aggregating raw data, so in the case where maybe you can't analyze the data trends at the source, or you don't necessarily know, or you need to take multiple data sources to understand what is occurring, then you'll need to look at big data analytical platforms that utilize predictive analytics, data mining, statistical analysis, and data visualization tools. Traditional relational databases may not be able to support the massive amounts of data that you're investigating, so you may need to look at the newer classes of technology based on the Hadoop framework, which is used to collect and process and analyze big data. It's a Java-based programming framework that makes it possible to run applications on systems with thousands of nodes involving thousands of terabytes of data, and is used by large companies like Google, Yahoo, and IBM to perform analysis on big data. Finally, in looking at the challenges of the industrial Internet of Things, we need to make sure we take into consideration security. We need to make sure that we take care to understand what your data is being communicated to. So if you're on an internal network, most likely you're going to be safe. And as long as there's not an attack on that network from the external, the security of the information is there. But we want to make sure that it's also secure from internal information networks that you may or may not want to have exposed. The next thing is you need to make sure that you also understand what's being shared across a private to public domain. So if everything is within your firewall, then obviously you're on your private network. If you're communicating to the cloud, if you're using big analytics in the cloud to help analyze that data, if you're using cloud-based solutions for applications, then you need to make sure that you're looking at the communication protocols and their security across that private to the public domain to ensure that data is secure. You need to make sure that not only that the standards that are being used, but also the protocols, as we talked before, are being secure, and the transport layer that they're being used on is secure. Finally, make sure that you only share what is required. We talked about this before. It helps with some of the big data issues. But again, sharing just for sharing's sake can open you up into an unmanageable situation of managing security. So take into consideration to only share what is required. So these are just some of the challenges that you would need to investigate and understand as you start to implement a strategy around the industrial Internet of Things. The next thing I'd like to talk about are some of the benefits that can be gained out of this new technology implementation. Benefits that can be gleaned from this are the ability to improve preventive maintenance efficiency, to be able to enable predictive maintenance methods, automate equipment failure tracking, and increase overall equipment effectiveness. So how do we improve preventive maintenance efficiency? It can be more cost-effective to schedule preventive maintenance activities by cycle counts or runtime when equipment has a variable utilization schedule. So the easiest implementation of a PM schedule in most systems today would be to put them on a recurring calendar event and then having the system generate that event or generate that work order, and you go out and perform the restorative or, for example, the replacing or reconditioning of the components to run more effectively and with high reliability. But it can give you that's the most simplest, and probably the most common implemented solution today. The reason that it is because if you base it on meter readings and cycle counts, obviously you have to be able to collect those, and you have to be able to collect those on a frequency that they can be utilized to generate the work that is necessary. But if you have that information, which is, again, the Industrial Internet of Things gives you the capability of doing, then you have the capability of implementing a strategy that's not based solely on a calendar, but can be based on actually how much the equipment is being used. This could mean that you could move a monthly or a quarterly PM out to months or semi-annual based on how much the equipment is being utilized. For another example, or an example of this, if you had a part casting operation, then the number of parts that are being cast is an important part of information that's being tracked already today in your production automation software. Each shot on the cast will be collected. If you can take that information and communicate it to your work order management system, then those cycle counts can be utilized to drive the restorative work order for that mold. So in the case of one customer that I had, we were able to implement a strategy of sending in the recordings for those cycle counts. Then we could generate on the frequency. They knew that at a certain number of counts was about the time when they needed to take it out of service and recondition the molds so that they could continue to produce a high-quality product with no off-quality. Now, if we had tried to have done that with just a calendar reading, then the work order would have come out. We would have had just to see whether or not they'd actually had that many shots on the mold. And that wouldn't have been a very effective way. Most likely those work orders either would have come out and they would have been over PMing the molds, or the molds could have, they could be under PMing the molds if those shot counts went down or went up, and they actually were creating more parts than they had expected. So by utilizing the integration between the production automation software and the asset management systems, we were able to automate the cycle count recordings, which in turn allowed them to have the work orders generated on the actual usage of the molds as opposed to a calendar base. This leads to more effective PM programs, higher quality, and as most of us know, the more times that you touch something, the more times that you potentially can cause operator and maintenance technician induced failure. So this improves that also. The next thing that we can look at is that we can enable predictive maintenance methods. As you are moving your strategy of asset management You'll probably start, if you're at the beginning, you're going to be starting at a position of just being reactive and collecting information on what is failing and then responding to that. And a system can help you improve by understanding what you're doing. The next step is you want to make sure that you're trying to implement a preventive maintenance schedule. And as we've said before, that could be something that's on a calendar basis, or it can be something that with the Industrial Internet of Things, you can start to implement a usage basis preventive maintenance program. But because of the way that some things fail and that they don't have a wear-out pattern, they fail randomly, and that they give you a warning that they're about to fail and give you time to react to that warning, a predictive maintenance methodology for asset management can be the most effective way to manage your operations. To do this, you want to measure important operating parameters through automated software. It enables effective preventive maintenance programs to turn into predictive maintenance programs. By tracking the operating parameters, such as temperatures and pressures or quality, all of which represent equipment health, trends can be identified and can even indicate potential equipment failures. Rather than communicate to the asset management system manually, so again, carrying that pad and paper around and then going to a terminal and typing these in some cases, which you could have error in the communication of the information, now you can ensure that software, that automation of those systems with the Internet of Things, the data collection and corrective work orders can be created so the technicians can adequately investigate trends that may indicate a potential failure. Some other things, you can look at production rates. Remember that we talked about the goal a few minutes ago, and one of the key components of overall equipment effectiveness is the performance rate. So by looking at how many parts are being created or units of whatever you manufacture be created, then we can look at as that starts to slow down, we can say that we need to go out and investigate and understand what's going on with that piece of equipment, and the work order can be generated to do that. If we're using the Industrial Internet of Things, we can also pull in data from other sensors that may help us understand and get a cleaner and clearer picture of what the issue may be. Another simple implementation of the Industrial Internet of Things is just looking at the energy consumption on a piece of equipment. As it starts to fail, as it starts to become corroded or dirty or have additional friction, you'll see your energy consumption start to go up. And so you could actually use that operating parameter. And we talked about some protocols that are being utilized in that space in the Industrial Internet of Things, and looking at industrial energy consumption to be able to use that as a predictive technique to understanding when a piece of equipment should be evaluated for corrective maintenance. Another benefit that you get out of the Industrial Internet of Things, and kind of similar to key operating parameters, is that in your automation software, your production automation software, as well as in your sensors and devices that are being implemented throughout the facilities, you can use standard failure codes to communicate issues to the technician before he or she goes on site, and this can increase efficiency and troubleshooting. So instead of just saying that the machine is not running or I'm having a problem, by utilizing the technology that's available in the coding of these sensors and devices, or just as simply just using your production automation software for your users to input failure reasons, can help your technicians be more effective and efficient before they get to that emergency call out. So by helping and utilizing this information, the production automation software collects the information, can automatically create the corrective work order for the emergency breakdown. That automation integration will support more efficient work order generation and identify operating measures that can result in more productive, predictive maintenance asset strategy. So again, when the technician gets to the site, he has a lot more information to help him troubleshoot what the issue may truly be. Of course, all of this leads to an increase in overall equipment effectiveness, improvement in equipment reliability, equipment performance, and quality. Once automated, create a process to use the data. With the aforementioned considerations in place, equipment data should indicate warnings before equipment failures so that you can catch things before they break down, leading to improved equipment reliability and uptime. They should also begin to slow, or before something starts to slow down, equipment performance. And if you see a decrease in first run quality, then obviously now you start to see that I have a problem and I can create work order to go out and investigate and remediate that problem. Data can be used to analyze where the opportunities to improve operations. So again, not only can it help you with your day-to-day workflow of work orders, you can also utilize it to understand where your key areas of improvement lie and what may be able to be utilized to make those improvements. More automation integration will produce better data, more reliable data, and the better analysis can be a key focus area in your plant operations. So that is all that I had prepared for today. Again, the goal of this presentation was to introduce you to the Industrial Internet of Things, some of the considerations of it, and some of the benefits that can be gleaned out of an implementation. We'd like to invite you to join us next April, April 30th through May 3rd at the Raleigh Convention Center for Dude University, where you can get information not only about the Industrial Internet of Things, but all of your operational needs.
Dwayne, thank you so much for your time, and thank you everyone that came on. Again, this was really great and really insightful, Dwayne, especially for me also as a novice to this. I really appreciate it, and again, yes, it would be great if you could join us at Duke University next year, university2017.com. You can get more information, and there will also be a lot of different types of thought leadership presentations. So we do invite everybody in the manufacturing sphere to come join us there. If you have any questions that you want to send to Dwayne individually, you can see his email now on the screen, and you can reach out to him at any time there individually, and we will also send you the recording. So we really appreciate it again for you joining, and I'll go ahead and unmute everyone in case there is a question that you don't want to type and you just want to go ahead and ask right now.
The conference has been unmuted.
Okay, it sounds like there's not too many questions coming in yet, so again, if there's anything you think of later, please just email Dwayne at dwayne.divers@dudesolutions.com. Dwayne, do you have anything else for this group?
Oh, no, that'll be it for this morning.
Thank you so much.
The conference has been muted.